Okay, good morning. I'm going to show you in this video how to graph absolute value inequalities. So these are absolute value functions that use less than or equal to, or greater than or equal to, less than or equal to, less than, and greater than. I'm going to write the form for all absolute value functions. It's y equals, but we're going to change that equals to one of these symbols up here. A times the quantity, or the absolute value of x, minus h plus k. So let's I'm going to just make up one. I'm going to say let's graph y is greater than 1/2 x plus 3 minus 4. Okay? Now this really looks really similar to y equals 1/2 times the absolute value of x plus 3 minus 4. And that looks a lot like our form, but the only difference was this symbol, and that comes in a little later. Where do we shade? What kind of line do we use? And we'll get to that. But first, what you want to do is find your A, H, and K. A is equal to 1/2. That's the number or the coefficient from the absolute value signs. And then H, well, this one's equal to -3. Now, why is it not +3? Because the form has this negative sign. If I substitute -3 in for H, I have two negatives. That's what makes it a positive here. So H is equal to -3, and sometimes it's easier just to take the opposite for H. Okay, and then K is equal to -4. That means the vertex of this absolute value function is at -3, -4. So let's plot -3, -4. 1, 2, 3, 1, 2, 3, 4. I went to the left 3, down 4. These are all units of 1, so that's where the vertex is. And I always like to draw a dotted line or dashed line, vertical line, because absolute value functions look like V's, and these are all symmetrical. Now, by inspecting A is greater than 0, so that means that this V opens up. Okay, and then I'm going to use the rules of slope. So this is going to look like a right side of V. I'm going to use the rules of slope. I have 1/2. That's rise over run. So I go up 1 to the right 2. So I'll go up 1 to the right 2. And then I use the axis of symmetry. Going directly across, we have this point is 2 units away from the axis of symmetry on the right hand side. In order for this to be symmetrical, a way that I can just fold everything on top of each other is to go 2 units to the left of the axis of symmetry, like so. Now, before you start drawing your line with your straight edge, you need to look at these symbols. Okay, the inequality symbol. If the inequality symbol does not have the or equal to bar, or that bar underneath those signs, these right here need to be dashed lines, while greater than or equal to or less than or equal to, these need to be solid lines. So since looking at this, I got y is greater than 1/2 times the absolute value of x plus 3 minus 4. I have greater than, does not have an or equal to bar, so I'm going to go ahead and use a dashed line, like so. Okay. And so. Okay. Now, what you want to do is look at the symbol. One way you can do this is, well, y has to be greater than. So it has to be above the line or within the V, inside the V. If it was less than, it would be below the line or outside the V. However, sometimes it gets a little confusing. The best thing you can do is always take a test point. Choose a point that does not lie directly on the line, like 0, 0. Okay, 0, 0 does not lie directly on the dotted line, so I can use that as a test point. This point is inside the V or above the line. So we go ahead and choose 0, 0 and substitute it back into our original inequality. We have 0 is greater than 1/2 0 plus 3 minus 4. Okay, 0 plus 3 is 3. Absolute value is 3. So 3 times 1/2, that's equal to 3/2 minus 4, or 1.5 minus 4. Okay, when I do that, I subtract. It's early. Let me make sure. I get 0 is greater than negative 2.5. That is a true statement. Okay, that point came from above the line or within inside the V, so I would shade everything above the line or inside the V. Okay, inside the absolute value function. All right, let's do one more just because this one's kind of a trickier one. So let's go down here and let's say we want to graph y is less than or equal to, let's do something like 4 times the absolute value of x minus 2 minus 3. Okay? Again, the form of absolute value functions are y equals a times the quantity x, or absolute value of x minus h plus k. Looking at this inequality right here, we can find a, h, and k. A is equal to 4. H is equal to positive 2. Remember the sign, take the opposite. And 3 is negative 3 is k. That means the vertex is at 2, negative 3. A is positive, so that means this opens up. And I have a less than or equal to bar. I'm going to use a solid line. Okay, I got all my information. I'm going to go ahead and plot the vertex. Go over to the right 2, down negative 3. Here's my vertex. Then I use a vertical line, dotted line, just to kind of give me the sense of where my axis of symmetry is. I use A like slope. It's not slope because we have absolute. It's not absolute for absolute value functions, but if it's equal to 4, I can write this as 4 over 1. That means I go up 4 to the right 1. Go up 4, 1, 2, 3, 4, to the right 1. Here's my other point. Okay, that point is 1 unit away from the axis of symmetry, so I go 1 unit to the other side, which is left, and I get that point. Looking at the symbol, I know I'm going to use a solid line, so I'm going to use a solid line like so. Now this is a real narrow V compared to the parent graph, y equals absolute value of x, and we have such. Now it just becomes a matter of where do we shade. Okay, this is less than or equal to, so you want to shade below the line or outside the V. So I know I'm going to shade outside the V. Okay, but just to be safe, I'm going to use a test point. I'm not going to use 0, 0. I'll go ahead and use, you could use 0, 0. It's not on the line, but just for sake, I'm going to take negative 2, 0 as my test point. It's outside the V, it's below the line, so I'm going to go ahead and substitute what I know into the original inequality right here. From the point 0 less than or equal to 4 times the absolute value of negative 2 minus 2 minus 3. Okay, I get 0 is less than or equal to negative 2 minus 2 is negative 4. Absolute value of negative 4 is positive 4. 4 times 4 is equal to 16 minus 3. And then what I get is 0 is less than or equal to 13, which is true. Okay, so that's a true statement. My test point came from an area that was true, so this belongs part of the solution set. So what I'm going to do is shade outside the V. Okay, and you can get really into your shading if you like, but as long as I can really tell that you're shading outside the V, you don't necessarily need to make this absolutely perfect. Okay, that should be good enough. I'm going to stop this video.